Okay, I wanted to show you guys an example that we're going to do in class together. This is an example that we did in class together. And then the sock logic was something the students did on their own. So we talked about payroll, and we all kind of understand payroll. So each week you have how many hours you worked that week. So most people, maybe if they're full-time, would be 40 hours a week. Then you also have to times that by how much you get paid per hour, and that's going to be your weekly pay. Then every 2 weeks you get 2 weeks worth of pay usually. So we were talking about how this is more of a computer realistic kind of something you would code for a computer, more realistic than the socks would be for actual coding. But this is a good example to show how the computer would really need to have quite a bit of detail for this to happen. So the students would, I'd ask them what they know about payroll, and I would make that the process. So usually they'll come up with, salary times hours for the week or whatever, and that's what they understand of payroll. Now with the computer, you're going to really have to be specific if you want to build a program that's going to run payroll, because you have things like taxes and you have things like overtime. But in addition, you also need to tell the computer, you need input. You need to go to the database and find all the employees and what they make and how many hours they had that week. You're going to have to output it to the screen. So there's all these extra things that we have to really think through the logic of it. So let me just quickly jot what I would do on the boards. This will kind of be a little sloppier with some of my diamonds and things I'm making here. But usually you'll have an oval or a circle that shows the beginning and ending, and I do show them the different flowchart symbols. Again, I let them know that they could do this in pseudocode as well. You don't have to build a flowchart. It's very visual, so I'm like just to do the pseudocode, which is just writing down the steps in human type language. So I would put maybe start on this one, and I'd explain, this might be them pressing the payroll button or whatever that might be to start the program. Then usually you're going to have an arrow, and coming down to start asking about, is there more than 40 hours or not? So I'll usually start with the decision, which is actually a diamond. So I'm going to kind of make a diamond here, because I don't think they've got a preset. There are better flowchart software, by the way, but I usually just do this on the board. Okay, so this one would be, if they have overtime, there's going to have to be a decision made. Are there hours greater than 40 or over 40? However you want to word that. This is just for them to understand. You don't have to get into syntax here. And then I would say if this is no, then that's when we're going to go here. So I would put the word no right there. And then if that is a yes, oops, I'm kind of unequal there, aren't I? Then I'm going to come down here and do something different. And I'm going to, hours over the 40 times 1.5 times or something like that. So they know that we're going to be doing something different over here. Then we'll have to still add the 40 into that, the regular 40. So it's going to look similar to this one. And you could even make a subroutine that would call the same code there. So this might not be exactly like you're going to code it, but we're getting the logic down here. Salary times hours for the 40. And then you could put something like and add, or this could be another rectangle, and add to the overtime, something like that. So you can have another bit of code that's going to do that. And so you can see the decisions that are going to need to be made here. And then I talked to him about, are you done? How many employees did this do? We don't know. We don't know where the information is coming from. We have no input. We have no output. They didn't see it on the screen. They didn't get their check printed. We don't even know where the information is coming from. So the computer has to know all of that as well. So usually I'm going to come back up here and I'll put the input and output are usually represented on like a parallelogram like this. And I would put something like employee info. So I explained that this could be a database that this is coming from that shows how much they make and how many hours they worked. It could be coming from time cards. It could be coming from you as the payroll person just inputting that because you got it in front of you from another program. I don't know. Wherever that input's coming from, which could be a whole nother little process in itself, but that's something that's definitely needed here. So each employee is going to go through each of these codes. So then I say, and we still don't have any output. We still don't know what happened because nothing's coming out on the screen. So we do need to represent the output here, and I'll usually come through like this and come down here, and I'll use the same kind of parallelogram shape. It's a little easier when I'm on the board. Okay, and then I'll put either the screen, let's see that I clicked the right thing. Let's see where that's typing, hold on. Okay, screen, output, or check got printed, whatever that might be as output here. Okay, so they can actually see. Then we talk about, okay, one time through all of this did one person. So what do we need to do to go through every single employee? So we have a decision here. So we're going to have a whole lecture just on decisions, and we're actually going to have a whole week just on loops. So we're going to be looping through each employee again and again and again until all the employee's information has gone through. So we actually show that process by coming down here and looping, whoops, up. Whoa, that should be a straight line there. And there's going to be another decision here that's going to say okay, it's going to say are there more employees to check? Do we have more employees to go through their information and give them a check? If that's a no, and I didn't leave quite enough room here, but the no would be right here, and you would actually stop the program right there. Or end, or whatever you want to use. And that was a no. If it is a yes, then you're going to go to the next employee, get their information, and loop through this information again. Okay, so maybe my flowchart wasn't perfect, but they get the idea. Now all of a sudden, the one little thing you knew about salaries, or the little bit of overtime you knew, there's so much more that we have to tell the computer in order for our system to really work. And so that's just kind of an in-class example I do. I will go over and I'll say, you know, you can have some pseudocode that does the same thing, and we'll go through and we'll say, you know, start the program, get employee information, and then check if that employee worked greater than 40 hours. If no, then salary times hours. Else, and this is getting more of the syntax, or they could say if yes, whatever helps them. Else, find out overtime with greater than 40 hours times 1.5 times. Add to salary times 40 hours. And then you would say output that employee information, loop back to checking next employee. And as they get to know the syntax better, they might come up here and say, while there are employees, then check to see, and then loop back if there's more employee information. Anyway, that's getting a little closer to what the syntax in the programming languages be. But as long as their logic is right, that's the idea. So they don't have to do both. They could do either pseudocode or a flowchart, whichever one that they want to do. So maybe I'd have this over on another side of the board. Okay, so that's the idea with something you can do in class to give them a little bit of a heads up of how they might go about doing their SOX logic.